The Kardashev scale is a method of measuring a civilization's level of technological advancement, based on the amount of energy a civilization is able to utilize directed towards communication. The scale has three designated categories called Type 1, 2, and 3. A Type 1 civilization is able to utilize and store energy available from its neighboring star which reaches their planet. Type 2 is able to harness the energy of the entire star, and Type 3 civilization are galactic travelers and possess knowledge of everything having to do with energy. The scale is hypothetical, and regards energy consumption on a cosmic scale. It was first proposed in 1964 by the Soviet astronomer Nikolai Kardashev. Various extensions of the scale have been proposed since, from a wider range of power levels to the use of metrics other than pure power. Definition. In 1964, Kardashev defined three levels of civilizations, based on the order of magnitude of power available to them. Type 1, technological level close to the level presently attained on Earth, with energy consumption at 4 times 1019 erg/sec. Guillermo A. Le stated this is a level near contemporary terrestrial civilization with an energy capability equivalent to the solar insolation on Earth. Between 1016 and 1017 watts. Type 2, a civilization capable of harnessing the energy radiated by its own star, for example, the stage of successful construction of a Dyson sphere, with energy consumption at 4 times 1033 erg/sec. Le stated this is a civilization capable of utilizing and channeling the entire radiation output of its star. The energy utilization would then be comparable to the luminosity of our Sun, about 4 times 1033 erg/sec. Type 3, a civilization in possession of energy on the scale of its own galaxy, with energy consumption at 4 times 1044 erg/sec. Le stated this is a civilization with access to the power comparable to the luminosity of the entire Milky Way galaxy, about 4 times 1044 erg/sec. Current status of human civilization. Michio Kaku suggested that humans may attain Type 1 status in 100 to 200 years, Type 2 status in a few thousand years, and Type 3 status in 100,000 to a million years. Carl Sagan suggested defining intermediate values by interpolating and extrapolating the values given above for types I, 2 and 3, which would produce the formula, where value K is a civilization's Kardashev rating and P is the power it uses, in watts. Using this extrapolation, a Type 0 civilization, not defined by Kardashev, would control about 1 megawatt of power, and humanity's civilization type as of 1973 was about 0.7 as the value for 1970s humanity. In 2012, total world energy consumption was 553 exajoules, equivalent to an average power consumption of 17.54 terawatts. Observational evidence. In 2015, a study of galactic mid-infrared emissions came to the conclusion that Kardashev Type 3 civilizations are either very rare or do not exist in the local universe. On October 14, 2015, the realization of a strange pattern of light surrounding star KIC 8,462,852 has raised speculation that a Dyson sphere may have been discovered. Energy development. Type 1 civilization methods. Large-scale application of fusion power. According to mass energy equivalence, Type 1 implies the conversion of about 2 kilograms of matter to energy per second. An equivalent energy release could theoretically be achieved by fusing approximately 280 kilograms of hydrogen into helium per second, a rate roughly equivalent to 8.9 times 109 kilograms year. A cubic km of water contains about 1,011 kilograms of hydrogen, and the Earth's oceans contain about 1.3 times 109 cubic km of water. meaning that humans on Earth could sustain this rate of consumption over geological timescales. In terms of available hydrogen, antimatter in large quantities would have a mechanism to produce power on a scale several magnitudes above our current level of technology. In antimatter-matter collisions, the entire rest mass of the particles is converted to radiant energy. Their energy density is about 4 orders of magnitude greater than that from using nuclear fission, and about 2 orders of magnitude greater than the best possible yield from fusion. The reaction of 1 kilogram of antimatter with 1 kilogram of matter would produce 1.8 times 10^17 J of energy. Although antimatter is sometimes proposed as a source of energy, this does not appear feasible. Artificially producing antimatter, according to current understanding of the laws of physics, involves first converting energy into mass, so no net gain results. Artificially created antimatter is only usable as a medium of energy storage, not as an energy source, unless future technological developments allow the conversion of ordinary matter into antimatter. Theoretically, humans may in the future have the capability to cultivate and harvest a number of naturally occurring sources of antimatter, renewable energy through converting sunlight into electricity, either by using solar cells and concentrating solar power or indirectly through wind and hydroelectric power. There is no known way for human civilization to use the equivalent of the Earth's total absorbed solar energy without completely coating the surface with human-made structures, which is not feasible with current technology. However, if a civilization constructed very large space-based solar power satellites, Type 1 power levels might become achievable. These could convert sunlight to microwave power and beam that to collectors on Earth. Type 2 civilization methods. Type 2 civilizations might use the same techniques employed by a Type 1 civilization, but applied to a large number of planets in a large number of solar systems. A Dyson sphere or Dyson swarm and similar constructs are hypothetical megastructures originally described by Freeman Dyson as a system of orbiting solar power satellites meant to enclose a star completely and capture most or all of its energy output. Perhaps a more exotic means to generate usable energy would be to feed a stellar mass into a black hole, and collect photons emitted by the accretion disk. Less exotic would be simply to capture photons already escaping from the accretion disk, reducing a black hole's angular momentum, known as the Penrose process. Star lifting is a process where an advanced civilization could remove a substantial portion of a star's matter in a controlled manner for other uses. Antimatter is likely to be produced as an industrial byproduct of a number of mega-scale engineering processes and therefore could be recycled in multiple star systems of a sufficiently large number of stars, absorbing a small but significant fraction of the output of each individual star. Type 3 civilization methods. Type 3 civilizations might use the same techniques employed by a Type 2 civilization, but applied to all possible stars of one or more galaxies individually. They may also be able to tap into the energy released from the supermassive black holes which are believed to exist at the center of most galaxies. White holes, if they exist, theoretically could provide large amounts of energy from collecting the matter propelling outwards. Capturing the energy of gamma-ray bursts is another theoretically possible power source for a highly advanced civilization. The emissions from quasars can be readily compared to those of small active galaxies and could provide a massive power source if collectible. Civilization implications. There are many historical examples of human civilization undergoing large-scale transitions, such as the Industrial Revolution. The transition between Kardashev scale levels could potentially represent similarly dramatic periods of social upheaval, since they entail surpassing the hard limits of the resources available in a civilization's existing territory. A common speculation suggests that the transition from Type 0 to Type 1 might carry a strong risk of self-destruction since, in some scenarios, there would no longer be room for further expansion on the civilization's home planet, as in a Malthusian catastrophe. Excessive use of energy without adequate disposal of heat, for example, could plausibly make the planet of a civilization approaching Type 1 unsuitable to the biology of the dominant life forms and their food sources. If Earth is an example, then sea temperatures in excess of 35 C would jeopardize marine life and make the cooling of mammals to temperatures suitable for their metabolism difficult if not impossible. Of course, these theoretical speculations may not become problems in reality thanks to evolution or the application of future engineering and technology. Also, by the time a civilization reaches Type 1, it may have colonized other planets or created O'Neill-type colonies, so that waste heat could be distributed throughout the solar system. Extensions to the original scale. Many extensions and modifications to the Kardashev scale have been proposed. Type 4 Kardashev rating. The most straightforward extend the scale to even more hypothetical Type 4 beings who can control or use the entire universe, or Type 5 who control collections of universes. The power output of the visible universe is within a few orders of magnitude of 1045 W. Such a civilization approaches or surpasses the limits of speculation based on current scientific understanding, and may not be possible. Type 4 Kardashev Kaku ratings. Kardashev alternate rating characteristics. Other proposed changes to the scale use different metrics such as mastery of systems, amount of information used, or progress in control of the very small as opposed to the very large. Planet mastery. Metrics other than pure power usage have also been proposed. One is mastery of a planet, system or galaxy rather than considering energy alone. Information mastery. Alternatively, Carl Sagan suggested adding another dimension in addition to pure energy usage: the information available to the civilization. He assigned the letter A to represent 106 unique bits of information and each successive letter to represent an order of magnitude increase, so that a level Z civilization would have 1031 bits. In this classification, 1973 Earth is a 0.7H civilization, with access to 1013 bits of information. Sagan believed that no civilization has yet reached level Z, conjecturing that so much unique information would exceed that of all the intelligent species in a galactic supercluster, and observing that the universe is not old enough to exchange information effectively over larger distances. The information and energy axes are not strictly interdependent, so that even a level Z civilization would not need to be Kardashev type. Microdimensional mastery. John D. Barrow. Going by the fact that humans have found it more cost-effective to extend any abilities to manipulate their environment over increasingly smaller dimensions rather than increasingly larger ones, reverses the classification downward from Type- to Type Omega-. Type- is capable of manipulating objects over the scale of themselves, building structures, mining, joining and breaking solids. Type- is capable of manipulating genes and altering the development of living things, transplanting or replacing parts of themselves, reading and engineering their genetic code. Type- is capable of manipulating molecules and molecular bonds, creating new materials. Type- is capable of manipulating individual atoms, creating nanotechnologies on the atomic scale and creating complex forms of artificial life. Type- is capable of manipulating the atomic nucleus and engineering the nucleons that compose it. Type- is capable of manipulating the most elementary particles of matter to create organized complexity among populations of elementary particles, culminating in Type Omega- is capable of manipulating the basic structure of space and time. According to this scale, human civilization is between III and IV-. Civilizational range. Robert Zubrin adapts the Kardashev scale to refer to how widespread a civilization is in space, rather than to its energy use. In his definition, a Type 1 civilization has spread across its planet. A Type 2 has extensive colonies in its respective stellar system, and a Type 3 has colonized its galaxy. Criticism. It has been argued that, because we cannot understand advanced civilizations, we cannot predict their behavior. Thus, the Kardashev scale may not be relevant or useful for classifying extraterrestrial civilizations. This central argument is found in the book Evolving the Alien: The Science of Extraterrestrial Life.